Hi, this session is about reader and writer. The objectives are read from CSV files, read from JSON files, write data frame to files, write data frame to tables, write data frame to a delta table. So I have done the classroom setup. So the data frame reader, it is an interface used to load a data frame from external storage systems. So we say spark.read.parquet and path to the files. Read from the CSV files. So we have the user CSV path and the dataset is equal to spark.read.option, which is a separator, which is a tab dot option header is 2 dot option info schema is 2 and dot csv, which is a user CSV path, and then we print the schema. And the schema, what we find is that it is a user ID, which is a column, string, which is a data type, and a constraint where nullable is equal to true. There, here also we are having user first touch timestamp long nullable is equal to true. We are having email and string where nullable is equal to true. The Spark's Python API also allows you to specify the data frame reader options as parameters to the CSV method. We have the data set is equal to spark.read.csv, the user CSV path, the separator is tab, the header is 2 and the infer schema is 2. And then we can print the schema again. We can see that the schema is printed here. We can manually define the schema by creating a struct type with column names and data types. So here we are creating the user defined schema, which is a struct type, and the fields are the struct fields. One of them is described as the struct field user ID string type true when nullable is 2. User first touch timestamp, which is a long type, which is 2. Email string type, which is 2. Read from CSV using this user defined schema instead of inferring from the schema. Here the difference is that we are using dot schema as a user defined schema. Alternatively, we can define the schema using the DDL syntax. Here the DDL schema is user ID string, user first touch string, first touch timestamp long, email string, and here also we are specifying the schema as a DDL schema. We can read from JSON files using the spark.read.option info schema true.json method events JSON dataset. Read faster by creating a struct type with schema names and data types. Here it is a complicated structure, therefore we can see here, say suppose the e-commerce, which is a struct type, and we have got within the struct type we have got several struct fields: the purchase revenue, total item quantity, and unique items. Similarly, items, which is a struct field, which is an array type, and it has got various, which is also a structure, and within the structure it has got, every structure has got the struct fields like coupon, item ID, item name, item revenue in USD, price in USD, and quantity. You can use a struct type scalar method to DDL to have a DDL formatted string created for you. This is convenient when you need to get the DDL formatted string for ingesting CSV and JSON, but you do not want to handcraft it for the struct type variant of the schema. This functionality is not available in Python, but the power of notebooks allows us to use both languages. We use a trick to transfer the value, the dataset path between Python and Scala using the shared Spark config, which is whatever your scope.events, the events JSON path. We will shift to the Scala scale here by doing %Scala, and we can get the events JSON path from this config. We can get the event schema, and here we are using the infer schema true dot JSON, and then we are getting the schema, and then we are getting the DDL, and then we can print the DDL, which is seen here. So once we print the DDL, we can see that this is a DDL that we are having here. which is a device string, comma struct, and so forth. And what we will do here is that we will use this and assigning it to a variable as we are seeing it here. So once we assign it, we can read in the JSON using our new DDL formatted string. This is a great trick for producing a schema for a net new dataset and for accelerating development. Warning, do not use this trick in production. The inference of a schema can be really slow as it forces a full read on the source dataset to infer the schema. DataFrame Writer interface used to write a data frame to external storage systems. The format is df.write.option, compression is snappy, and the mode is overwrite and parquet output directory. Here we are having the output directory and we are using the user's df.write.option, compression snappy mode override, and we are writing .parquet in parquet format to the output directory. We can display the details of the files by doing the dbutils.fs.ls, which is found here. As with the DataFrame reader, Spark's Python API also allows you to specify the DataFrame writer options as parameters to the Parquet method. We can use by the dataframe.write.parquet, and the user's output directory compression is snappy and the mode is override. We can write the data frames to tables with events df to a table using the data frame writer method save as table. This creates a global table unlike the local view created by the data frame method create or replace temp view. So it is the dataset.write.mode overrides save as table events. We can see the database where it is printed by using the print database da.db name. We can show even the tables in the database by show tables in da.db name. Delta Lake. In almost all cases, the best practice is to use the Delta Lake format, especially whenever the data will be referenced from a Databricks workspace. Delta Lake is an open source technology designed to work with Spark to bring reliability to data lakes. Delta Lake's features, it has got ACID transactions, scalable metadata handling, unified streaming and batch processing, time travel, schema enforcement and evolution, audit history, Parquet format, and compatible with Apache Spark API. We write results to a delta table using the format the dataset.write.format delta.mode override.save to the path. Hope you like this lecture on reader and writer. Thank you. Bye.